Okay, let's jump right into this explainer. Today, we are looking at AWS safe deployment strategies and risk management. We're going to tackle a very high-stakes reality that every developer faces, which is controlling your production blast radius during an application update. Because let's be honest, the truth is, a single deployment can literally make or break your application's uptime. So I want to show you exactly how safe deployment strategies work in the real world and exactly how you need to execute them if you're taking the DVA-C02 exam. I want you to imagine this scenario. It's late, you push what you think is a quick, harmless code update directly to your live servers. But a tiny, unexpected bug in that new code crashes the application. Suddenly, it takes your entire system offline. Users are blocked, errors are spiking, it's a total disaster. Well, good AWS engineers never let this happen. They use safe deployment strategies to strictly control their production blast radius. The core mental model you absolutely must adopt today is simple. Safe deployment strategies strictly reduce risk. You don't just overwrite live code. Instead, you isolate the new version and you transition your traffic safely. All right, let's look at strategy number 1, the gold standard, blue/green deployments. So blue/green deployment is a strategy that absolutely minimizes your downtime and your risk. And it does this by running 2 identical production environments. We call them blue and green. Now, here is the key difference. Only one of these environments serves live production traffic at any given time, while the other one is being updated. Once your testing is completely finished, your traffic is simply switched or routed over to that new environment. Think about it like a really busy restaurant. If you want to upgrade, instead of closing down your business to remodel the kitchen, you literally build a brand new, fully functioning kitchen right next door. Your chefs can go in, they can practice in the new kitchen, figure out the quirks, all while the old kitchen is still happily serving your real customers. And once that new kitchen is absolutely perfect, you simply swap the signs on the front doors. Now, to actually build this out in AWS, we rely on a specific set of services. We use things like AWS Elastic Beanstalk, AWS Code Deploy, Amazon Route 53, and Elastic Load Balancing. Each of these services gives us specific ways to implement the routing and the shifting of our traffic back and forth between those 2 environments. Let's actually walk through the exact sequence of how this happens. For example, if we're on an EC2 compute platform, the instances in your deployment group, that's your original environment, are replaced by a completely different set of instances in a replacement environment. First, code deploy provisions those new instances, and the absolute latest application revision is installed on them. Then, an optional wait time occurs. This is for activities like deep application testing and system verification. Think about that for a second. You have all the time in the world to run automated tests against these new servers because absolutely 0 real users are touching them yet. Then, once you're confident, instances in that replacement environment are registered with an Elastic Load Balancer, which causes the traffic to be seamlessly rerouted to them. Finally, the instances in your original old environment are deregistered. From there, they can either be terminated to save money, or you can keep them running for a bit just in case.
Okay, moving on to strategy number 2, the pragmatic alternative, Canary deployments.
Now, you might be wondering, what if you don't want to double your compute costs by running 2 massive, identical environments at the same time? Or what if you actually want to test the new code on your real users, but you want to do it very, very safely? Well, instead of a massive switch, you use traffic shifting. You might route just 10% of your live traffic over to the new version, while keeping 90% of your users safely on the old version. Think about the power of that. If your new code has a hidden memory leak that didn't show up in testing, only 10% of your users experience a slight slowdown, and you can instantly pull them back to safety. You have completely contained the blast radius of that bug. So tying this back, the absolutely crucial point for the DVA-C02 exam is this. You manage these application environments in individual AWS services by differentiating between your development, your test, and your production stages in API Gateway. You can actually use existing runtime configurations to create dynamic deployments. A great example is using staging variables from API Gateway directly in your Lambda functions. You can also safely test applications using Lambda versions and aliases. It's pretty cool. You simply configure a Lambda alias with routing weights, and that allows you to slowly, carefully shift traffic from the old version over to the new version. All right, strategy 3, and pay close attention here because this is where people mess up. The pitfall, the rolling deployment trap. A lot of teams default to using a rolling deployment instead. In a rolling deployment, AWS updates your instances in batches. So it takes down maybe 5 instances, upgrades them, puts them back into service, and then moves on to the next 5. Seems logical, right? But if that deployment fails halfway through, you have a massive problem. You now have a split brain environment. Literally, half your users are seeing the old code and half are seeing the new, broken code.
And the worst part? Rolling back from that state is a slow, painful, manual process. You are risking serious failure and extended downtime.
Now imagine this. You do the smart thing. You launch a Canary deployment. But how does AWS actually know if the new version is failing in the background? That is the ultimate safety net question we have to answer. The answer is you must instrument your code for observability. Good engineers don't just deploy, they implement an effective logging strategy to record exact application behavior. They add annotations for tracing services, and crucially, they implement code that emits custom metrics. Why? Because if those custom metrics suddenly spike, say error rates shoot through the roof, your pipeline automatically detects it. You can then perform automated application rollbacks by using those existing deployment strategies. Code deploy instantly shifts the load balancer traffic right back to the original instances, and your application effectively self-heals with zero downtime. All right, let's wrap this up. Let's lock this down. 3 rapid takeaways. Takeaway number 1. Blue/green deployments minimize your risk by running 2 identical environments, and they use a load balancer to seamlessly reroute traffic only once your testing is totally complete. Takeaway number 2. You configure deployment strategies like Canary or rolling deployments to strictly limit exactly how many users are exposed to brand new code at any one time. And takeaway number 3. You absolutely must instrument your code for observability. That way, if an update fails, your pipeline can instantly perform an application rollback using your deployment strategy. I want to leave you with one final crucial warning to think about. Deploying without monitoring is deploying blind. Never, ever assume a deployment succeeded just because the build finished compiling. If you aren't monitoring your traffic shifts and you aren't configuring automatic rollbacks, you are still deploying blind. So keep your blast radius small, instrument your code, and stay safe out there.